Tech Talks Education, we are proceeding with organic chemistry and we're looking at methods of preparation of alkanes. So far discussed one, and that was reduction of alkenes. And now we are going to method 2, which is also reduction of alkynes. Reduction of alkynes. So I still want to say reduction of alkynes also involves addition of hydrogen, nickel catalyst, and at 150 degrees Celsius. But however, like I said, it is also possible to use palladium or platinum. Palladium or platinum, but these ones additions take place at room temperature. They would really take place, the reactions are even active at room temperature. Now, we still talked about Markovnikov's rule. Markovnikov's rule is still very valid for as long as we're looking at non-symmetrical alkynes. And the non-symmetrical alkynes, this could be one of the examples. That is one example of a non-symmetrical alkyne. Around the triple bond, we have different number of hydrogen atoms on these carbons. This carbon doesn't have any hydrogen, but this carbon has got one hydrogen. So such an alkyne is non-symmetrical. But when we look at this alkyne is symmetrical. So if it is a symmetrical alkyne, then addition of hydrogen goes anywhere. It really goes anywhere because whatever is formed will be a stable carbocation, will be a stable carbocation. But for such a non-symmetrical alkynes, addition of hydrogen would strictly go to carbon 1. That's where it will go, so that you can produce a positive charge on this carbon, and that provides us with a much more stable carbocation, which is secondary. Now we can proceed ahead and look at an example of addition of hydrogen in the presence of nickel catalyst and at 150 degrees Celsius. Only that we need to note that alkynes have 2 pi bonds. They have 2 pi bonds. So during addition of hydrogen, we add 2 moles of hydrogen so that they can replace the 2 pi bonds that are going to be broken in the process of the reaction. But alkenes have got only one pi bond. So since they have only 1 pi bond, then they need 1 mole of hydrogen. 1 mole of hydrogen is enough for the reaction of 1 pi bond, and then there remains a sigma bond which does not participate in chemical reactions. But for alkynes, since they have 2 pi bonds, then they need 2 hydrogen molecules in order to completely reduce the 2 pi bonds in order to form the alkanes with only 1 sigma bond. Now, take an example of a compound like this. said alkenes, alkynes would need 2 moles of hydrogen, then nickel catalyst at 150 degrees C. They needed 2 moles because 1 mole removes 1 bond. 1 mole removes, like for example, the lower bond, and another mole removes the upper bond. And by the process, we end up forming a very good alkane. Now we start the reaction, but I want to say that these alkynes now, forget about this. This is not participating in the chemical reactions because this is not a reaction of the benzene ring, but it's only a reaction of the alkyne. So the hydrogens only affect the double bonds which are here. So that's what we're trying to look at. So we still proceed with our mechanism. Sorry. We donate electrons to that hydrogen atom, and after donating its electrons, then this bond breaks away so that we gain stability. Then from there we get a secondary carbocation. Looking at this, if this is carbon 1 and that is carbon 2, Markovnikov rule says the hydrogen atom being added should go to carbon with more hydrogens. Because when it goes to carbon with more hydrogens, that is when we obtain a more stable carbocation. But suppose it went to this carbon atom, then you get a primary carbocation, which is less stable than a secondary carbocation. So we get then this one carrying a positive charge, then plus a hydride which has broken off. Now this hydride is now electron rich, or we can call it a nucleophile. It goes ahead to also donate electrons to the electron deficient species in order to have it stabilized also. We have compound like that one. This is now an alkene, and we're saying that the alkyne had 2 pi bonds. One of them has been broken and hydrogen added, so reduced to alkenes. Then this alkene also has 1 pi bond, which can also be reduced by additional hydrogen until an alkane is formed from an alkene. So I want to go ahead and say we are still also donating this to a second molecule. Remember, there were 2 molecules of hydrogen. So one of them has reacted and one of them has now remained. So that would finally give us something like that. Now, this carbocation that is formed finally receives electrons from that hydride liberated. it finally receives electrons from this hydride liberated, so that we are able to finally form okay. So now this compound formed has saturated bonds only. We want to call it an alkane because it doesn't have any pi electrons. So therefore, this one we call it phenyl. Phenylethane. While this one is called phenyl. That one is called phenylethane. That is the preparation of alkanes from alkynes.